Next up, we'll look at the language of polynomials. There's a little bit of preamble here about polynomials, but what we need to realize is we need to work out the degree of a polynomial. That's really handy to know. That is the index n of the leading terms. So just say we've got a polynomial p of x equals 3x to the 5 plus 2x plus 1, then this is the degree. It's a degree 5 polynomial. Knowing the degree of a polynomial helps understand what the shape will be, how the function is going to behave, etc. A monic polynomial is a polynomial whose leading term has a coefficient of 1, so this is what we call a non-monic polynomial. That just helps if you're trying to work out how to factorize it, do things like that to it. The constant term is a term of index 0. This is the term, or is the term not involving x. So this would be the example of the constant term. Right, let's try out some of these questions or these examples. P of x is this. Find p of negative 1. So p of negative 1. What we're going to do is slam negative 1 in. So we get negative 1. Negative 1 when squared is 1 times negative 3 is negative 3 plus 1. They cancel out, leaving us with negative 3. Find p of x take 1. So p of x take 1 equals x take 1 to the 3, take 3, x take 1 to the 2 plus 1. Do we need to expand that? Not really. They didn't tell us what form they wanted it in. They just said, can you do p of x take 1? And that is p of x take 1. So unless they tell us to expand it all out, we're going to leave it as that. Right, state a transformation from p of x to p of x take 1. Well, whenever I put x take 1 into a function, what that is, or what it represents, is a translation 1 unit to the right. How do I know? Well, think about it. If p of x equals x squared, and I make a new function, g of x equals p of x take 1, then g of x will equal x take 1 all squared. And that's just the standard parabola. That's the standard parabola moved 1 to the right. All right, this one here. Okay, so q of x equals this. Q of negative 1 is the same as q of 2, which is equal to 0. So basically it's saying if you drop negative 1 in to q of x, you're going to get 0, and if you drop 2 in, you're going to get 0 as well. And what we want to do is find a and b. Alright, so let's drop negative 1 in. So we're going to say 0, so q of x is equal to 0 when I replace all of these x's with negative 1s. So negative 1 to the 6 is 1, that's going to be 2. Take, now negative 1 to the 3 is negative 1, so that's plus 1. No, plus 1, that's negative 1 squared, that's going to be plus a, take b plus 20, and 0 equals 23 plus a, take b. And I can sort of see what's going to happen. This is going to be a simultaneous equation, a take b, and I don't know, for whatever reason, I just like to have constant and the two terms I'm trying to find on the right hand side or the left hand side. Okay, so I'm going to drop 2 in. Alright, now this is going to get a little tricky. 2 to the 6, I think that's 64. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. Multiplied by 2 is 128. Take away 8 plus 4a plus 2b plus 20 equals 0. That's 140 plus 4a plus 2b equals 0. 4a plus 2b equals negative 140. Alright, so what I'll do is I want to eliminate b, so I'm going to multiply this whole thing by 2. Negative 46 equals 2a, take 2b. Now I'm going to add them together. So b's are going to cancel out or eliminate. I'm going to get 6a equals negative 46, that's going to be negative 186. Now I'm going to put 6 into that, so you could set it up as division if you wanted. but I can see that it's going to go in there -3 and 1, -31 times. Alright, now what we'll do is we'll pop a equals -31 into here, into this rather. So -23 equals -31, take b, add 31 to both sides, 8 equals -b, b equals -8. There's my value of a and b. Alright, so this was on the 2014 exam, and what we got, roughly 1 in 2 students got A right, bit less for B, 7% for C. That's really low. Okay, that's really low statewide, and 19% got D. Right, let's try them out. So we've got f of x is equal to this, and g of x is equal to that. And we want to express this g of x function in this form here. So what we'll do is we'll go g of x equals, so I can see that an x has been factored out, so we'll take it out as a common factor, x cubed take 8. Alright, now what I'm going to do then is I'm going to get the calculator to factorize that, and what it should do is give us something like this part here, so it looks like this. We can pair up the coefficients, etc. So here we go, we're going to factor, so action, transform and factor, and what we'll do is we'll feed it x cubed take 8. Alright, so it's close to it, x take 2, x squared plus 2x plus 4. Now what we'll do is that checks out, this one here, we need to get it into turning point form, so what we'll do is we'll just complete the square on that. G of x equals x take 2, what's that going to be? X squared plus 2x plus 1 squared, take 1 plus 4, that's going to be x plus 1 all squared plus 3. Okay, that looks good. Okay, so express that in that form, done. Okay, describe the translation. So they're telling us what the transformation is. It's a translation that moves f of x onto g of x. So here's f of x and here is g of x. So what moves that to that? On the surface seems actually quite tricky to work out the transformations if you go from there to there. But you got to question, why did they get us to do this particular question here? Right? Why did we do this? And the answer is because when I express this in this form, it gives us a clue about what's going to happen. Alright, now, if you think about this, g of x here, if you note that if I do g of x take 1, what that will do is g of x take 1 will, when I slam in x take 1, that's going to change to x take 1. That's going to change to x take 1 take 2, which is x take 3. And that's going to change to x take 1 plus 1, which is x squared plus 3. And g of x take 1 is this, which actually is f of x. So this is our transformation. So the transformation is a translation 1 unit to the right. So all g of x is f of x, all g of x is f of x moved 1 unit to the right. I think I have fucked this up. Okay, on to some work on polynomial functions from the 2014 exam. And you can see the state struggled with this question with 1 in 2 students getting question A right, B was 37, C was a very low 7%. That's quite low. And D, the state bounded or rebounded there and got 19% on that one. Okay, so the first part of it requires us to express, well, what is it? We've got f of x, which is that, and g of x, which is that. So they're both quartic functions. We want to express this quartic in this form. Okay. So what we'll do is we'll say that g of x equals, what I'll do is yank x out as a common factor, x cubed take away 8. Then what I think will happen is when I factorize that, it'll turn into something like this. So I'm going to get x, and then that factorized should equal the stuff inside the brackets. Action factor x cubed take 8. Close. X take 2, x squared plus 2x plus 4. So what we got out of it is a trinomial, and we want that trinomial to be in this form, which all we would do to that is then complete the square on it to turn it into turning point form. So that's going to be x squared plus 2x plus 1 squared take 1 plus 4. X plus 1 all squared plus 3. Alright, and we've got it into the correct form now. Now this seems a little weird, like why do we want it in that form here? So this will be a hint, okay? They're telling us something here. So anytime you do something in a methods paper and you're not really sure why you did it, like the examiners don't get you to do this just for kicks. They want you to know something, alright? That they want you to know that you can get this quartic into this form, which looks a little bit like this form. Alright, describe the translation that maps f of x onto the graph of g of x. Okay, so what do I do to f of x to turn it into g of x? What would I do to this function here? So, and I know it's a translation. Okay, so a translation can be, like I could have a vertical translation or a horizontal translation. I'll be willing to bet it's a vertical translation. So equals g of x. Alright, now here's my original function f of x. Now what do I do to this to get it to look like this? To get it to look like g of x, and this is also g of x. Well, if you have a look by inspection, what would happen if I dropped in x plus 1? Alright, let's put x plus 1 in. So I've got x plus 1 take 3 is x take 2. So that's there. I've got x plus 1 goes in. X plus 1 take 1 is just x, which is that. And x plus 1 goes in here, which is x plus 1 all squared plus 3, which is just this. So this is the transformation that takes it to g of x, which is a translation 1 unit left. Alright, so here is the 7% question. So let's see how we go in that one. Find the values of d such that the graph of y equals f of x plus d has one positive x-axis intercept. Alright, so these questions are relatively common, and I think the best way to do them is as follows. What we'll do is shift 7 for a define, and what we'll do is define f of x. So there it is there. Okay, so let's go and have a look. So we're going to go to menu and graph and table. All right, and shift 8 for f of x, check and graph. All right, so there is f of x. All right, so find the values of d such that the graph of f of x plus d has one positive x-axis intercept. So what we want to do is translate it such that the x-intercepts, so what's going to happen, we want to move it to the left. Okay, we want to send this graph to the left. So if you think, let's just sort of do a rough sketch. 1, 3. So here it is at the moment. So what we want to do is move it to the left so that it has one positive x-axis intercept. So I think what we'll do is we can move it, so we're going to say that D is an element. Okay, now if I move it there, 1 to the left, what that's going to mean is it's going to be to 2 to 0. Okay, so if I move it 1 to the left, that's going to get it to 0, which gives us one positive x-axis intercept, and I can keep on moving it another 2 units across. So that's going to be up to 3. I can shift the original one 3. So I think that's the answer, and here's how to check it. So the usual way I do these questions here is f of x plus d. So what I do is I introduce the parameter to the graph and hit not the leftmost graph button, but the one next to it. It's this one here. Alright, now what that will do is bring up a slider here, and what you can see when d is equal to 1, we get this is the x-axis intercept at 0, 0, so it's got one positive x-axis intercept. And what should happen if I increase it to 2, it should still have one positive x-axis intercept. There it is. By the time it clicks over to 3, okay, it will have no positive x-axis intercepts because this one here is at 0. So that's why we go 3 up to, but not including 3 itself. So up to 3 will still have an x-axis intercept, but 3 itself then will mean that that value there is on 0. So you can see that's a 1 mark question, and everything would have had to have been right to get that 1 mark, and you can see why it's a toughie. Right, 2 positive x-axis intercepts. Well, what I think is that it'll be D is an element. Right, let's go back to the original one, which is 1. All right, now you can see here that what we've got is one positive x-axis intercept. If I go any lower than 1, what's going to happen is I'm going to get 2 positive x-axis intercepts. So you can see here that it's the values from 1 not including it, okay, because this is 1 itself, and this has got one positive x-axis intercept. Okay, but when I go lower, we're going to get our 2 positive x-axis intercepts. All right, so let's bring it back. Now, the problem with mine is that I've gone 1, comma, I can't put negative infinity now, so I've just got to swap that around so that negative infinity comes first. Up to 1, not including. Alright, so there's 1, and then that's the highest value up to, but not including it itself. Any less than that, we're going to get 2 positive x-axis intercepts. Whew, tough question. Okay, so if this is the same as this, find the values of a and b. Okay, so this is a classic equating coefficients problem. So what we're going to do is match this with this. We're going to try and get this into the same form as this. So to do that, what I need to do is expand this perfect cube. 1, 1, 1, 2, 1, 1, 3, 3, 1. All right, so these are going to be the coefficients. So it's going to be a 1, x cubed 1 to the 0, which is 1. So there's our first one. 3, x squared 1 squared. 3x 1, 3x, and 1 cubed, which is 1 plus b. So now we're going to expand it out. Ax cubed plus 3ax squared plus 3ax plus a plus b. Alright, now what we can do is equate our coefficients. So we're going to say that a is equal to 1 because A is in the position that this is in, and if this is the same as this, then A has to equal 1. We can test it out. 3 times 1 is equal to 3. 3 times 1 is equal to 3, so it checks out. Now, over here we know that A plus B is the constant term, and we know that that is the constant term, which is 8. So now we're just going to bang 1 plus B equals 8. We just put our value for A that we just found in. B is equal to 7. So find the values of A and B. That's done. Show that this cannot be written in this form for real numbers A, B, and C. So I think what will happen with these ones here is if you try to equate coefficients, something funny happens. I've done this one before over the years, so I just know that if I use that technique, what will happen is I won't be able to equate coefficients properly. So unlike this one here, it just won't work out such that the coefficients, or that the A and B value will produce the same set of coefficients. Right, let's see how we go anyway. So I'm going to say that x cubed plus 6x squared plus 6x plus 8. I'm going to try and write it in this form here. So it's going to be A. Now this is going to be, so remember Pascal, 1, 1, 1, 2, 1, 1, 3, 3, 1. It's going to be x cubed, c to the 0, which is 1, plus 3x squared c plus 3x c to the 2 plus c to the 3 plus b. Okay, so far so good. Ax cubed plus 3ac x squared plus, I'm just expanding the a here, 3ac squared plus ac to the 3 plus b. Okay, so now it's time to equate coefficients. So what I'm going to do is, straight away I can see that a is equal to 1 because this is the coefficient here, and if they were the same, then this would be the coefficient here. Alright, now we'll do this one here. So I've got 3ac equals 6. Now if a is equal to 1, that means 3c is equal to 6 and c is equal to 2. So it's looking okay so far. A is equal to 1 and c is equal to 2. Let's just try it on this one here, which is 3ac squared. That should be an x in there as well. So what I'm going to do is pop in my values, so 3ac squared, and what should happen is that will equal 6. So 3ac squared should equal 6 if this is true. Okay, if c is equal to 2 and a is equal to 1. So 3 times 1 times 2 squared is equal to 4 equals 6. 12 is equal to 6. Uh-oh. So here you can see that this is not the case. Right, so 3ac squared is not equal to 6. These aren't equal to each other, therefore cannot be written in the form required because it doesn't make it true. There's no values that make it true. Alright, so there's our questions there for homework, so 4C and the binomial theorem.